You are embarking on a new journey, and this is the journey of proofs. Proofs can be a little daunting to begin with, but with practice you will get better. So be reassured that you will learn how to do a proof all by your very self. Proofs can be algebraic or geometric. Today we're going to concentrate on a proof in geometry. We're going to begin by taking a proof that has statements filled in so that it doesn't become too difficult in the beginning. A proof has a starting point and an ending point, and the starting point is your given and the ending point is your proof statement. So you start with whatever is given and try and prove the last thing. In this case, we are given EF equals GH. What does that mean? That means the measures of EF and GH are equal. So what I am going to do is I am going to mark those. These are that EF is equal to GH. You'll notice that statement number 1 says EF equals GH, and the reason I can say that is that this is a given. Now, I notice that in order to prove that EG is equal in measure to FH, all I have to do is add FG to both EF and GH. So I am going to make a statement which seems very redundant to you, but the statement is FG equals FG. This is the reflexive. Okay, let's get that right. If I can find my eraser, here we go. Okay, let's get back the pen. Reflexive property of, and look at this sign, equality. Now, if you look at statements 1 and 2, and if I were to put a plus sign here and a plus sign there, what are we doing? We're adding statement 1 to statement 2 to get statement 3. So I am going to say addition property of equality. Note that number 2 and 3 are algebraic properties. Number 4. Now number 4 is interesting. I have learned in geometry that EG plus FG, which are two collinear adjacent segments, that EF plus FG is the same as EG. So this is supported by segment addition postulate. Okay, same thing, FH equals FG plus G, that is also segment addition postulate. So now what I can do is I can, let's erase this. Let's use some colors here. If you will see that in 3, I can substitute 4, and in 3, instead of FG plus GH, I can substitute FH, which gives me statement 6. So how am I going to write this? I am going to say substituting in 3, that means I'm saying statement 3 using statements 4 and 5. So EG equals FH. So I'm getting closer to what I wanted to prove, except there's a little difference. What I want to prove is that they are congruent. I know that by definition, if two segments are equal in measure, then they are congruent. So this is definition of congruency. So your last statement, statement 7, is what you started out to prove. So in a proof, the last statement is always what you wanted to prove. So that wasn't too bad. Now what we're going to do is we're going to move on to a proof which we are going to do from scratch. We're just going to brainstorm it. We will not be given any statements or any reasons, but not to worry. Let's look at this proof. Okay, what are we given here? Oh, same thing. We are given AB is equal to CD, and we want to prove that AC is equal to BD, equal to, note, not congruent to, it is equal to. So the first thing I'm going to do is write my given. I can always do that in a proof. AB, oh, let's do a little color change here. So let's use blue. Okay. Hello. AB equals CD, and that's a given. Note that I have numbers on both sides, and that's important. There's a protocol in proofs that you must follow. Proofs read top down. Statements on the left are supported by reasons on the right. So AB equals CD. So what do I need to do now? I need to add BC to both of them. So how am I going to do that? First thing I'm going to do is I'm going to say BC equals BC, and that is the reflexive property of equality. Aha! How about if I add AB and BC and CD and BC? So what I would do is I say AB plus BC equals CD plus BC. Remember, in an equation you can add the same thing to both sides of the equality. So this is addition property of equality. I just added BC to AB and CD. Okay. Next, I need to prove that AC equals BD, but I know that AC equals AB plus BC, and that is segment addition postulate. Similarly, I can say that, look at CD plus BC, that's BD equals CD plus BC, that is segment addition postulate also. So now if I look at 3, 4 and 5, I can substitute. Let's highlight. Instead of AB plus BC, what can I substitute? AC. And instead of CD plus BC, what can I substitute? BD. So what I will get is that AC equals BD, substituting in statement 3 using statements 4 and 5. And one more time, you have proven what you started out to prove. Okay? Do not be afraid if you don't quite get the hang of this yet. Practice will make perfect, and you will get there. Okay, this is the end.